yeah, really excited to have Othentic back to deliver a workshop on the hackathon. We have Yotam joining us here today to deliver his presentation and some run-throughs. So really looking forward to covering everything. As always, it will all be recorded. So if you don't get it first time following along live, do not worry, it will be recorded and you can watch back in your own time to make sure you've got everything nailed. But otherwise, that's everything from me. Great to see you all filtering in again. Good to see you joining in the chat. So yeah, Yotam, thank you for joining us, and I'll leave you to take it away.
Thank you, Roy. Thank you for having us. Hello, everybody. My name is Yotam. I lead the engineering team at Othentic. And today I'm going to talk a bit about Othentic, the Othentic Stack, what it is. I'm going to talk a bit about a couple of other things related to AVSs and what AVSs are and how they work. Excuse me. So yeah, let's get started. The agenda is pretty concise, so I'm gonna go over what is the Othentic Stack. I'm gonna talk a bit about proof of stake networks and how they operate. Then I'm gonna talk a bit about AVSs and how they operate and how they connect to, how are they related or connected to proof of stake networks. Then I'm gonna do a really quick overview of the Othentic Stack components. And at the end of the after the presentation, I'm gonna show a couple of demos of the Othentic CLI, how you can use it to deploy your own AVS, and I will be following the basically I will be following the workshop document that was shared in chat. So let's get started. So the Othentic Stack basically lets you leverage EigenLayer's protocol to build your own networks. Okay, so the Othentic Stack is a framework that lets you build off-chain computation networks, and it comes in the form of a set of building blocks, okay, that you can build and extend as you choose. So basically, the Othentic Stack lets you bridge the gap between EigenLayer's on-chain protocol and your own decentralized service. So let's start with proof of stake networks and ask ourselves, why do we need proof of stake? So the two common reasons you would want to use proof of stake is for Sybil resistance, meaning I want to prevent people from just joining the network without putting any assets or without putting any stake beforehand. And that's meant to prevent spam and all sorts of other issues. And the other thing is the slashing conditions. So the slashing conditions are the situations where I want to punish or penalize malicious actors. Okay, so if I identified some malicious behavior, I want to be able to punish these participants. But proof of stake networks, they present multiple challenges. And some of the main challenges are, if you build your own proof of stake network, you need to provide on-ramps for users to be able to actually buy your token, right? So unlike proof of work, where users can generate their own tokens, theoretically, in proof of stake, they have to be able to buy these tokens somehow. This also means that you need to create some utility for your token so that it will have demand, okay? And the last thing is that you need operators that have enough conviction in your token so that they not only buy it, but also hold it and stake it, right? So shared security protocols such as EigenLayer, they solve these challenges because basically what they do is they let these operators and these users, excuse me, basically use their Ethereum stake, and that actually makes it a lot easier for us to build networks that are based on that stake, that already existing stake. But it doesn't mean that the work is done. So we have a couple of things that are left if we want to build our own network. So there's a couple of things that we still need to take care of. One is the execution layer. So the execution logic, basically, like we need to determine how our network is going to operate and what are the rules and what is the logic of how this network operates. We also need to come up with some consensus mechanism. So how do these nodes in our network, how do they come to consensus on what is the correct state, or what is, whether a task or like a block or any sort of data is valid or invalid. So how do they come to the consensus on whether it's valid or invalid? And we also need to build some sort of P2P layer where these nodes can actually communicate with each other and come to the consensus. So this is a very simplified view of what a typical proof-of-stake network might look like. So we have all of these nodes, and if we zoom in on a single node, we find out that actually each node is running two different clients, okay? So it's not running a single client, it's running two different clients. It's running a consensus client, and it's running an execution client. And whenever a block proposer is chosen and they propose a block, okay, that block arrives to the consensus client of every node, and the consensus client takes the block data, sends it to the execution client. The execution client runs whatever calculations it needs to run in order to verify that the block is valid. And then it gives the consensus client an answer, whether this block is valid or invalid. The consensus client takes this result and attests to it and sends that attestation to the rest of the network. So a bit about AVSs. So AVSs try to utilize the shared security of EigenLayer. And in order to do that, they have to interact with the EigenLayer contracts on-chain. So that means that every AVS requires some on-chain components to exist so that they can communicate with the EigenLayer protocol. And the most basic things that you would usually want to, the reasons why you would usually want to have this on-chain component that communicates with EigenLayer is, first of all, you want to make sure that all your operators are actually staked with EigenLayer, so they actually have some stake, and they are, and that stake is slashable. You want to be able to distribute rewards to your operators, so that has to happen on chain. You also want to be able to slash malicious actors, also happens on chain, and you want to verify the task validity for every task or block or however you define it in your network. You want to verify that the task is valid on chain. Okay, so you want to have some sort of contract that is able to verify the task validity. And sometimes optionally, you would also want your AVS to be able to communicate with other contracts on the network. So this is how, this is a very high-level overview, or like a very simple view of what an AVS on-chain component might look like. And basically, it's a single contract, an AVS entry point, and that AVS entry point is a contract that knows that can communicate with the EigenLayer slasher, the delegation manager, etc., etc. There's a couple of other contracts as part of the EigenLayer protocol. And you might also have a couple of external contracts that your AVS entry point communicates with, but this is optional. Now, I will say that the AVS entry point, it can be either a single contract that does all of those different roles, or it could be a suite of contracts, and that we will talk a bit in a second. We will talk a bit more about it, but it could also be a suite of contracts, and that's what the Othentic Stack uses. So instead of a single AVS entry point, there's a suite of contracts that each have their own responsibilities. So if we look at an entire AVS, okay, if we look at an entire AVS system, so basically what we have here is we have the, let's call it the off-chain part, which is the consensus and execution part of the network. And then we have all these on-chain components, that their primary purpose is to communicate or interact with the EigenLayer protocol. And the Othentic Stack basically gives you some parts of the necessary components. Okay, so what we have here is that basically the two main parts that the Othentic Stack gives you are the Authentic CLI, which can be used to build your own consensus client, and what we call the attestation center, which is the entry point contract for all the different contracts that interact with EigenLayer. Okay, so the Othentic Stack gives you part of the solution. Okay, but it's important to understand that in order for you to build a fully featured AVS, there are still things that you need to implement on your own. and that's mainly the execution logic part. Okay, so the Authentic CLI client. So the Authentic client, it has an API that lets you communicate with an execution client. Okay, for those familiar with how Ethereum validators work, you might compare this to what's called the engine API. That's the API that is running between the consensus client and the execution client. So we expose a similar API, and it means that you can build your execution client in whatever language you want. Okay, so the Authentic CLI, the Authentic client, basically comes with all the consensus, P2P, BLS aggregation, all these features. It comes with those out of the box, but you still need to implement your AVS logic. Okay, so the actual logic of how your AVS will operate. And that logic you can implement in whatever language you want, as long as you expose the necessary endpoints, API endpoints, on your execution client, so that the Authentic client can communicate with it. So the Authentic Stack components, just again as a high-level overview, are split into two. So the smart contracts, as I mentioned, and the consensus client. And I will say that about the smart contracts, one unique thing about the Authentic Stack is that we let you, it's optional, but the Authentic Stack lets you split your contracts between an L1 and an L2. You could deploy everything on the same layer, but we highly recommend usually to deploy the verification contracts, the contract that can verify the attestations. We recommend deploying it on some layer 2, some rollup, mostly to save on gas costs. And the Authentic consensus client basically gives you the gossip sub-based P2P layer. It gives you the BLS aggregations of the attestations, and it's it has the extensible API, okay, that lets you basically write your execution client however you want. So one last thing I want to go over before I go over the demos, it's important for me to emphasize it. So what Authentic is not, okay? So I will say Authentic is an open stack. That means that it's not its own network, okay? So Authentic is not a network. Authentic is not an operator, and it's not an owner of any contract, okay? So every contract that you deploy using the Authentic CLI is your own contract, okay? It's not an Authentic contract. It's not under the control of Authentic contract of Authentic. It's under your full control, okay? So basically, you can think of Authentic as a suite of tools for building your own AVS network. So I'm going to show a couple of videos, a couple of demos for the CLI itself. I'm going to show how it works. I might skip a bit some parts because some of it we might not want to wait for the entire thing to go. There's a link. I think we put it, Rory put it in the chat. You can follow the instructions in that link. And you can try to follow as I show the demos, or you can do it later on in your spare time. But it should be very straightforward. What we're going to do is we're going to deploy one of our sample AVSs. So basically, it's an AVS. The AVS itself is going to be a very, very simple price oracle, and you are able to deploy it through our sample AVS repository, and basically run it and see it running within an hour. I mean, we usually do workshops, like hands-on workshops, where we deploy an AVS within an hour, and you can also do it on your own. Just follow the document. So I'm gonna start by showing these demos, and I'm gonna explain what's happening. So basically, we usually start by installing the Authentic CLI itself. Okay, so it's an NPM package. We just install it. I'm gonna skip all the dependencies stuff here. It's just installing the NPM package. Excuse me. Then what we do is we clone the AVS samples repository. and we create a .env file with a private key inside of it. Okay, so that private key, this private key that you put in the env file, that's your deployer account. Okay, so that's the private key that you're going to use for deploying your AVSs. So once you installed the Othentic CLI, and once you've cloned the AVS samples repository, you can create the .env file inside of your AVS samples repository, and that will be the private key that is used for deploying the contracts. So deploying the contracts is also an Othentic CLI command. So we do everything through the Othentic CLI. So the Othentic CLI has a network deploy command. The parameters you put in there, like the parameters that you pass the command, are explained in the workshop document, so you can go over it there. It's nothing too fancy. Basically, we want to tell we are deploying a suite of contracts. We're deploying it using Forge, as you can see here, for those familiar with Forge and Foundry. So we utilize Foundry a lot. We love the toolchain, and we highly recommend it. And what's happening basically is that we're deploying the set of contracts on the L2. In this case, it's a MOI. Okay, so a MOI is the Polygon testnet. So we're deploying the suite of contracts on the L2 on a MOI, and then we're deploying a suite of contracts on the L1. In this case, it's Holsky. So Holsky is where EigenLayer contracts are deployed, and we deploy on the same network. As you can see, the script here basically takes care of everything. I believe it takes something like 3 minutes, if I'm not mistaken. Yeah, 2.5 minutes. So I'm going to skip a bit ahead, just so that we don't have to watch the entire deployment process, but it takes like 2.5 minutes. At the end of it, what you get an output of all the contracts that have been deployed. And then I'm going to pause the video so I can go over all of them. Okay, great. Oh no. Back to the start. Okay, so great. So at the end of the deployment script, you get this list of contracts, and these are all the contracts that the Othentic Stack deploys for you. Okay, or some of them it deploys for you. I'm going to go over these contracts really quickly, or at least the important ones. So the ERC20 here, this is the contract. This is a contract that you provide, actually. So we don't deploy an ERC20, or the Othentic CLI doesn't deploy an ERC20 for you. It's like, this is the rewards token that you're going to use for your AVS. So you plan on rewarding operators with some token. So this is the token that you're going to use as rewards. For the demo purposes, it doesn't really matter. You can put any address that you want here. It doesn't really matter for if you're just running the sample AVS. Okay, so AVS governance, this is the contract that actually communicates with EigenLayer protocol, with any of the components that deal with operators. Okay, so the AVS governance is like, its main role is to track the operators that are registered for your AVS. So when you run your AVS, every operator that participates has to sign up to your AVS, and we're going to see it in a second how they do that. But an operator has to sign up to your AVS, and they do that through the AVS governance contract. The Vault contract holds your rewards token and is used to distribute rewards. And the L1 message handler, this is a contract that communicates with a bridging protocol, with a cross-chain messaging protocol, and that's the contract that communicates with the L2 contracts. Okay, so I'm not going to get into the details of exactly what this communication involves, but there's a couple of messages that are passed around between the L1 and the L2 here, and the message handler contracts, there are two of them. So we have the L1 message handler and we have the L2 message handler. So they communicate with each other. Again, not going to go over all the details, but that's their purpose. On the L2, the main contract that we care about is the attestation center. Okay, so the attestation center, this is the contract that verifies all of the attestations that your AVS produces. Okay, so when all of your operators, they each see a task. So someone performed a task, they sent it on the P2P layer. All of your nodes, they see this task now. They decide, they communicate with if you recall, you implement your execution logic. So all of the nodes, they run the Authentic client and the execution client. So the Authentic client receives this task. It passes it to the execution or the AVS logic, the AVS implementation. And the AVS implementation service decides whether this task is valid or invalid. The Authentic client signs the attestation, whether it's valid or invalid, whether the task is valid or invalid, and it submits it to an aggregator node that then aggregates it using a BLS scheme and submits that BLS signature to the attestation center. Okay, so the attestation center can validate, can verify the BLS signature of all the operators that signed a specific or that attested to a specific task. Okay. And this is used in a couple of different areas. It's used to calculate the rewards they deserve. In the different situation, it's used to calculate the slashing, the punishment that a malicious actor deserves. And it's also used, the attestation center is also extensible in the sense that it can also communicate with callbacks with other, like to invoke callbacks on other contracts that you can implement, that you can like extend the AVS logic on chain using these contracts. So this is the deployment part. Once we deployed our AVS, we can register our operators. And if you look in the workshop document, so we register 3 different operators. It doesn't really matter how many operators you register for your demos, but for the sample AVS, we register 3 of them. By the way, for those of you who see here a private key and think to themselves that they can steal something, then you're welcome to steal the 0.01 whole key ETH that is there. So this is the process of registering an operator. Basically, you enter your private key, you enter the AVS governance address, and there's a couple of questions here that you need to answer. When you register as an operator to EigenLayer, you need to do a couple of steps. So first of all, you need to actually stake some ETH. So if you don't have stETH for that operator account, then this command, the CLI command, will stake ETH for you to get stETH, and then it will also delegate that stETH to through the EigenLayer strategy manager. It will deposit it to the strategy using the delegation manager, as we can see here. And eventually it will also sign you up to the AVS. Now, one thing that you might have noticed here is that there's a couple of questions: operator name, description, all of that stuff. These are the details that will appear in the UI, or technically will appear in the UI, should appear in the UI. Basically, the details of your operator. I'm just gonna skip to that again so you can see it. So basically, you need to provide an operator name, a description for your operator, some website, and you can optionally give some logo URL and a Twitter profile. I've omitted these here, but you can either fill them in or leave them empty. For the testing, for testing purposes, it doesn't really matter. But what's important to notice here is that eventually we create a JSON file and we upload it to IPFS, and that's the metadata that is used for your operators and is presented in the EigenUI. And yeah, at the end of the process, you can see the confirmation that the operator is registered on this network. If you recall, this is the address of the attestation center. Okay, so this is the of the AVS governance. So basically, this means that this operator registered on this network, and this is the address of the operator I registered with, and I have a transaction hash here that I can go and verify on Etherscan, and see that it actually went successfully. So as part of the workshop, we register 3 of these operators, 3 different ones. There's also in the workshop document In the workshop document, there's a small bash script just to help you create these operators. If you want to just quickly create some operator with a small amount of ETH in it, then you can use that script. Should be fairly simple. And then you can use these operators to register. And again, for the AVS samples demo, you need to register 3 operators and then use them. In a second, we will see the basically the how we run the network. Okay, so yeah, so in the workshop document, you will see all the environment vars variables that you need to set in order to run the network itself. So there's a full list there. The document explains all the different vars that you need to input and what their values should be. And yeah, you can just follow that. But once you've set up your environment variables, then you can run the actual AVS. And in the demo, for the demo purposes, how the AVS is running, it's running inside of a Docker Compose system, and basically it's running a couple of different containers. Each container has, excuse me, each container is responsible for a different part. So we have basically what we have in the container is we have an aggregator node, we have 3 tester nodes, and we have the execution logic implemented as its own service. And all of the tester nodes, they communicate with that execution logic. Okay, so all of the different nodes, they communicate with that service. And every time they see a task, they go to that service and they ask it whether that task is valid. And we're going to see it in the demo here. I'm just explaining it a bit before because the logs here run really fast. So I'm just explaining what we're about to see, but I will also pause it as it's going, and I will show you the different steps in the process. So basically, I run the Docker Compose. It starts up. All the nodes connect to each other, and then once I execute a task, we can see that the messages are being received by all the different nodes, and eventually a task will be submitted on chain, and all of that happens automatically, and the nodes, they come to their own consensus about the tasks. I will just go over it a bit. Excuse me. Go over it a bit, just so I can show different stages here of the process. So, okay, so here we can see basically that all the nodes are connected to each other. And once a task arrives, so we can see here we have executing task, we have the proof of task here. Not going to go into the details of what the proof of task means, but basically what's happening here is that there is some service that takes a price of USDT ETH, I believe, and basically it publishes that price to all the nodes in the network. All the nodes check that price. They check whether they contact their own API, their own price feed, and they check whether the price that the task performer is actually close enough to the price that they see. And if it is, then they approve it and they attest that the task is valid. And if not, then they reject it. They reject the task. So what we see here is that we see the task is created and then it's submitted. Okay, so it's submitted through a JSON RPC API. And then all the different nodes, they receive that new task. Okay, so we have the new message received, we have the proof of task here, and they all start to validate the task. So I'm just gonna skip a bit ahead. Okay, so we can see here with the AVS Web API container here that it's validating all of these tasks, or it validates these tasks. It's validating this task 3 times because it has 3 different attesters here. So each attester contacts the AVS Web API and asks it to validate whether the task is correct or not. The voting is approved. Okay, so we can see here that they all vote approve. And then they start signing this task. Each node signs it separately. and eventually the aggregator starts aggregating them. And we will start seeing here all these messages from the aggregator service, like adding attestation for task with label. And eventually, once the aggregator finishes aggregating all of these attestations, it submits it. It's very difficult to see because it's right at the last second, but I hope maybe no. So basically at the last second here, it's a bit difficult to see the submission itself, but basically at the last second here, the task is submitted on chain. It's really difficult to see, but trust me that it's there. And again, if you follow along with the workshop document, you will see it live yourself. These demos, by the way, I mean, you can also, I recorded them. Basically, excuse me. So I recorded them basically one after the other. So they should represent the oops. They should represent how an actual deployment process looks like. So let me just pause this video, just a second. Okay. Oops. Yeah. So I hope this was interesting to you all. Hope it gave you a good idea of what the Othentic Stack gives you. I think that as you can see, what we try to do is we try to build something that is easy to use, that is extensible, that lets you build whatever AVS that you want. And we have lots of examples, or like, we have lots of teams, lots of projects working with us, completely different AVSs, completely different logic, execution logic, and the point of the Othentic Stack is that it gives you a blank canvas to create whatever AVS you want. So thank you very much. And if there are any questions, we can take them now.
Yotam, thank you so much. Really enjoyed the videos. They worked very well. It was a nice way to run through everything. And as we say, we have the docs as well, which I've periodically been dropping in the chat. I'll do so again now, just to make sure everybody has those. And for anyone watching the recording of this rather than live, we'll make sure that they're sent over to you as well, so you don't miss out. But as Yotam said, everything we've gone through today, I believe, is captured in those docs, right? So everyone should be able to follow over there. Yotam, where can people kind of keep in touch with what you're working on at Othentic? I know you've shared some links there, but is there a place in particular that you would direct people if they want to reach out and get in touch with your team?
Yeah, so I will share again in the chat. I will share the docs website that we have.
Nice.
So that would be the best place to start. You can also contact us through our website. That's also an option. And we do plan on, we're working on creating better spaces for the community to contact us and talk to us. We have, as I said before, we have many teams working already using the Othentic Stack. So we do have a sort of a small community already of people working together and talking and sharing their experience. But we do plan on setting up, we are still working on it, but we do plan on setting up other spaces for the communities, such as Discord, Telegram, etc. Not live yet, so don't have any link to share, but you can follow the website. You can also follow the, I will also put actually the Twitter handle. So you can also follow us at 0x Authentic at Twitter, on X. I'm going to drop a link in the chat right now.
Perfect.
So that's also a great way to follow what's going on. Yeah, and
amazing. Thank you very much. Well, Archie, hopefully that answers your question. No Discord yet, but a great time to get involved nice and early. Follow the team over on Twitter, and then as they go live, you can make sure to get yourself involved. But yeah, once again, Yotam, just want to say thank you. I think we've got everything covered with the docs, so I'm sure if there are any questions after this, as people are reviewing the content and things like that, then of course you can refer to the docs and refer back to the recording to help out if you come across any issues. But otherwise, Yotam, any final remarks, any exciting kind of news you wish to share, then please feel free to do so.
Yeah, I mean, I will just answer. I think I see a question. Akshay asks, how do you deploy Slash an event manager contract? So I will just say these are contracts that are already deployed by EigenLayer. Okay, so these are part of the EigenLayer protocol, and the contracts that you deploy using the Othentic Stack are contracts that know how to communicate. So basically, you can think about it kind of like the Othentic Stack lets you deploy an abstraction layer, so a suite of contracts that make it a lot easier to talk to EigenLayer. Okay, so the EigenLayer APIs, they are very complicated. They involve all sorts of stuff like a BLS public key and all sorts of stuff that usually people don't want to deal with. So the Othentic Stack contracts, they just make it a lot easier. They simplify a lot of stuff for you, and they save you the trouble of actually implementing that yourself. Yeah, and I think that was the only other question that I saw here. Nice. So other than that, just want to say really thank you, Rory. Thank you for hosting us. It was really fun sharing with you what we're working on. As I said before, the best place is to check out the docs and follow us on Twitter or X, and we will keep updating there about the stack itself and different projects and teams that are working with us. And yeah, that's it. Thank you very much.
Awesome. Thank you very much. Thank you for answering that final question, which I missed. But yeah, great to clarify that final point. And as I said, do get involved, everybody. It's a great time to get involved. So hopefully today is the start of your journey with Othentic. So thank you one final time to Yotam, and thank you everybody for joining us once again. We will see you all tomorrow for the next workshop. Thank you and enjoy your evenings. Bye-bye.